Alright, 3.3. We'll start off with the product rule. So the product rule. Okay. So let's pretend you're taking the derivative. So of f of x times g of x. So there's two things being multiplied. That's why it's called the product. Here's what you're gonna do. You're gonna take, you see the very first function, and you're gonna leave it alone. You're just gonna rewrite it, and you're going to multiply it by the derivative of the second one. Then you're going to add, and you're going to take the derivative of the very first one and multiply it by the second function. Question for you. Would it matter if I would have done f prime of x times g of x plus? No, right? Because it's addition. Can we all agree with that? Right, so if I ask you for this rule on a quiz, I wouldn't really care if you give it to me exactly like that, but it needs to somehow match. In one side, you're taking the derivative of one of the functions times just the other function, and on the other side, you do the opposite. Cool? Alright, this can be extended to cover the product of more than two functions. So for example, you don't have to write this, but if you'd like to, let's say you had f of x times g of x times h of x. So let's say you have three functions being multiplied together, then you could do f prime of x times g of x times h of x plus f of x times g prime of x times h of x, right? And lastly, the last one would have to be f of x times g of x times h prime of x. So do you guys see how you can continue to do this if I have like a product of 10 functions? Wouldn't be any fun, but notice how each one of this is just making sure that you take the derivative of each function. Cool? Alright, let's do an example. Take the derivative of y equals x squared sine of x cosine of x. So what I mean by functions in the rule, you could technically say that x squared is one of the functions, sine of x is one of the functions, and cosine of x is one of the functions. Okay? I'll do this one with you guys, and then I'll let you try some on your own. So we're going to do the derivative of this, so it's going to be y prime equals, I'm going to take the derivative of the x squared, so the x squared becomes sine x and cosine x, plus, now I'm going to leave the x squared alone, and I'm going to multiply by the derivative of sine, which is cosine, and then multiply by cosine x, plus, now I'm going to leave the x squared alone, the sine x alone, and multiply by the derivative of cosine x, which is negative sine x. Alright, now I'm going to just kind of clean this up a little. So y prime equals, I'm going to leave this alone as 2x sine x cosine x. I'm going to rewrite this as x squared times cosine square of x. You guys okay with that? And then I'm going to rewrite this as, actually I don't need a plus there. You guys see how it's going to become a minus? So it's going to be minus x squared sine square x. Can I do anything else? Not really. I mean, you can continue to mess around with it a little bit, but it's really not going to get any prettier than that. And remember, on the AP exam, guys, if he doesn't tell you to simplify things, you could literally stop at this step right here. Okay? Reading the instructions on your AP exam is going to be essential so that you're not wasting time. Okay? One thing that I forgot that I'll mention to you is I was talking to Anj, and I didn't really think about this to mention it, but I will mention it. When we're doing the tangent line, notice how I always solve for y equals just y equals mx plus b. That's just me being picky. It doesn't tell you to do so, then leave it in point slope form. They're not going to take points away. If it doesn't specify any form, you can write it in whatever form you like. If you want to turn it to general, turn it to general. It's your call. But if you just want to leave it in point slope form, because they're not telling you to put it in any form, they will not mark it wrong or take points off. You can stop. So in other words, you got to just make sure that when you're reading your test, if it doesn't ask for a simplification, if it doesn't ask for a certain form, or it doesn't ask something specific, and you know you've done the calculus part of it, stop. They're not going to count it wrong. Just box your answer. Cool? Alright, so at this point I'm just going to say I'm good here. I don't really need to simplify anymore. Cool? Alright, so how about you try this one? So find the derivative of h of x equals 3x minus 2x squared times 5 plus 4x. So find the derivative of that one. And I'll go ahead and give you the other one in case you finish that one. You can also try y equals 2x cosine of x minus 2 sine of x. So take both of those equations there, those functions, and find the derivative of both, please. Alright, so I need you to check your work. So here's what's going to happen. If I'm going to take the derivative of this one, let's pretend I'm going to start and take the derivative of this first right here. So the derivative of 3x is 3. And then the derivative of negative 2x squared becomes negative 4x. So since I took the derivative of that, that means that I'm going to take this second part and just leave it alone. And then I'm going to add. Now on the other part, remember how I took the derivative of that? Well, now I'm going to leave it alone. So I'm going to say 3x minus 2x squared and multiply by the derivative of this one, which in our case would be the derivative of 5 is 0, and the derivative of 4x is going to be 4. We're going to simplify this thing out. 5 times 3 is 15. 4 times 3 is 12. 5 times 4 is negative 20 in this case. Negative 16x squared. Plus 4 times 3, that's 12x. Minus 8x squared. And finally, I'm just going to combine later and a negative 8x squared, which becomes negative 24x squared. I have a 12x and another 12x, so that's 24x minus 20x, that stays as a 4x, and lastly plus 15, and that would be my final answer. Okay, be careful. I feel like if you made a mistake, it wasn't your calculus, it was your algebra. Yes, sir. Okay, if, which I don't expect a problem to just be this simple given to you in a free response, I would have stopped right here. More than likely you're going to get a problem like this on the multiple choice part of it, and I guarantee you they will not just leave it like this. They're going to want you to simplify it, because none of the options will look like this. The options will be simplified versions of it, so you will have to simplify for the multiple choice part of it. Okay? Alright, for the second one, notice that we have a few things going on. First of all, I'm going to have to apply the product rule on this part of it. Agreed? And then I'm going to have to find the derivative of the negative 2 sine x. Okay? So we're going to do y prime equals. Alright, so there's a product here, so I'm going to take the derivative of the first term here. So the derivative of 2x is just 2, and I'm going to multiply by cosine x. Plus, I'm going to leave the 2x alone and find the derivative of cosine, which is negative sine. Okay, so I'm going to put this in parentheses. Minus, I need to find the derivative of this. Now, notice that you don't really have to apply the product rule here. If you remember your rules from last class, if you have a constant in the front, it's really, you just leave the constant alone. And what's the derivative of sine? Cosine, right? And now from here, technically, you're done differentiating. Just simplify things out. So y prime equals, we have 2 cosine x minus 2x sine x, agreed? Minus 2 cosine x, you don't really need this here. And you should notice then that the 2 cosines are going to cancel out, leaving you with negative 2x sine x as your final answer. Questions? Are we okay? Yes? Did we realize any mistakes that we may have made on the process? Alright, so if we don't have any more questions, then we're going to move on from the product rule into the quotient rule. Ready, guys? Alright, quotient rule. So the quotient rule. Alright, so let's say you're taking the derivative of two functions that are being divided. So here's what you're going to do. Here's what happens. Alright, notice what I have on the denominator here is g of x. So what you're going to do is, this is actually going to become a very long division. You're going to take the function or whatever was on your denominator, and you're going to just rewrite it just as it is on the top part. Then you are going to multiply that part by the derivative of the numerator. Then you're going to subtract the original function or whatever was on your numerator, derivative of your denominator. And last but not least, you're going to divide that entire thing by the function that was originally on the denominator, but you're going to have to square it. Now here's my question to you. If I rewrite this and I say g prime x times fx minus f prime x g of x all over gx squared, would that be the same thing as what I have here? Unfortunately, will not. You have to remember that with subtraction, the order matters. So it definitely matters in here. The first part, you have to make sure that it is the denominator rewritten exactly like it is times the derivative of the numerator, then minus the derivative of the denominator times the original whatever function or part you had on the numerator. Okay? So it is very essential here. The order does matter. Okay? So the order matters. And it's obviously stated for this to work, g of x cannot be 0. Can we agree with that? Otherwise, we wouldn't have a quotient. Alright, here's an example I'll work out with you. So let's pretend that you have f of x equals 5x minus 2 all over s1. And I ask you to derive it. Alright, very first step. F prime of x. So what do I do first? So your denominator was x squared plus 1, so I'm going to rewrite it just as it looks on the numerator. And I have to multiply that by what? The derivative of the numerator. So what is the derivative of your numerator? 5. I'm going to subtract. It tells me to leave whatever I had in the numerator exactly like it was, so 5x minus 2, and multiply it by the derivative of the denominator, which in our case would be what? 2x all over whatever you had on your denominator, so x squared plus 1 squared. Okay? From here it's just simple simplification. So f prime of x equals 5x squared plus 5 minus, so 5 times 2, that's 10x squared minus 4x all over notice what I'm going to do. I'm not really going to expand this out. I'm just going to leave it as x squared plus 1. There's really no need, okay? Last step, I'm just going to combine like terms. So I have 5x squared minus 10x squared. That becomes negative 5x squared. I have minus a negative 4x, so that becomes a plus 4x. And lastly, I have a plus 5 all over x squared plus 1 squared. And we are done with that problem, okay? Again, don't waste time trying to expand this out. You're going to take a long time trying to expand that part out. There's really no need. Questions? Are we ready to practice it? So I'm going to make this a little bit more challenging. So rather than me just giving you a problem just to derive, I'm actually going to give you a tangent problem to make connections so that you don't forget that we still can do tangent problems, okay? So I want you to find the equation of the tangent line to the function of x, that is 3 minus 1 over x, all over x plus 5, at the point negative 1, 1. Alright, so before I let you go, just a reminder, who remembers, first of all, how am I going to find the equation of a tangent line? What do I need to do? You're going to have to differentiate this for what? That helps you find the what? The slope of the function at any point. But because I'm giving you a point, once you derive it, you can plug in that value in there to find out the exact slope at that point, correct? Then you can find the tangent line, agreed? Alright, go for it. Alright. Number thing that I did is rewrote this. I've noticed some of you guys got common denominators and then divided out and whatnot. What I did, and there's nothing wrong with what you did, is I actually rewrote this as 3 minus x to the negative 1 power over x plus 5. Are you guys okay with that? And if you went the other direction, absolutely right. There's no problem. Okay? Then what I did is I started finding the derivative of this thing. Okay? So it is going to be x plus 5 times the derivative of the numerator. Right? Well, that 3 is going to go away. Agreed? Negative 1 times negative 1 becomes positive 1. Right? And then x to the negative 1 becomes x to the negative 2. Right? Minus. I'm going to leave my numerator alone. So 3 minus x to the negative 1 power. And multiply that by the derivative of the denominator, which in our case is 1. All over x plus 5 squared. Yes, sir. Of the numerator? Well, remember, if you want to find the derivative of a constant, what happens to the constant? 0. Okay, remember, a constant, the derivative is 0. So when you find the derivative of then the next term, remember, this is the power rule. We're going to take that negative 1 and multiply it by whatever we have on front here, which is a negative 1, right? So it becomes a positive 1. And then subtract 1, so that's where I got the negative 2. Cool? Alright, from here, I could try to start simplifying things, but there's really no need to. I'm not going to waste time. Because I've done the calculus, now I got to really go back to the question and say, well, I was looking for the slope, and I have a value of x, don't I? I can just go ahead and plug in that value for x. So I'm going to say f prime of negative 1. Agreed? So I'm going to plug it in. Negative 1 plus 5 becomes 4, right? Now, technically, we know this, and I'm just going to kind of go up here. This is the same thing as saying 1 over x squared. Agreed? So if I'm plugging in a negative 1 there, Negative 1 square is 1. 1 over 1 is, so times 1, right? Minus. This right here is technically what, guys? 3 minus 1 over x. Agreed? So if I'm plugging in negative 1, what's 1 divided by negative 1? Negative 1. 3 minus negative 1 becomes 4. Agreed? Times 1. All over. Negative 1 plus 5 is? It's what? I'm sorry? 4. Square. So I hope that by now you're noticing that this is 0 over 16. Right? Which means that your slope is 0. Agreed? Now that I have my slope, I can use point slope form, and this becomes y minus 1 equals to 0 times x plus 1, and I could leave it in that form. Or you will notice that that entire thing is going to cancel out. Y equals 1 could also be your answer. Okay? So what does that mean as far as me having a slope of 0 about that tangent line? What do you know about a line that has a slope of 0? It's what? Not undefined, but is it a horizontal or is it a vertical line? It's a horizontal line. So that wherever this happening at this function, that tangent line happens to be horizontal. Cool? Alright, questions. So you guys see now how I'm going to start making connections. Like, even though we've already talked about the tangent line, I'm going to continue to bring things and put the pieces together. Are we okay with the quotient rule? Okay. Alright, so then we're going to be able to use the quotient rule and the product rule to come up with the derivatives of the rest of the trig functions. The trig ratios, I'm sorry. So we know for sure sine and cosine. Agreed? Now we're going to figure out what secant, cosecant, tangent, and cotangent. Now, would I recommend that you memorize them? Sure. Do you have to? Not really, because you can derive them with your knowledge of sine and cosine. So we're going to find derivatives of the other trig functions. Okay? Alright, so now let's say, very first one, let's say f of x equals to tangent of x. So use what I'm telling you. So if we're going to use your knowledge of sine and cosine and product and quotient, how can you use all that knowledge to figure out the derivative of tangent? Why would you use a quotient? Great. So what if I rewrite? I'm going to take that f of x and I'm going to rewrite it as sine of x over cosine of x. Do you guys agree that that's the exact same thing? Right? Now at that point, could you use the quotient rule to differentiate this? Absolutely. F prime of x equals cosine of x times the derivative of sine, which is cosine, right? Minus sine of x times the derivative of cosine, which is negative sine, all over cosine x squared. Agreed? Now I'm just going to simplify things out. F prime of x, cosine of x times cosine of x becomes cosine square of x. This is going to become plus sine square of x all over cosine square of x. Agreed? Do you remember one of those Pythagorean identities that I asked for in the quiz? What do you notice on the numerator? Over, which technically reduces to be what? So now you know that the derivative of tangent x is what? Secant square of x. Yes? Can you say that one more time?
Tangent square of x plus 1
Okay. All right. Cool. All right. We're gonna derive the other ones together because I don't want to run out of time. So the next one would be let's do cotangent. So let's say g of x equals cotangent of x. All right. So for me to derive this, are we out of tissue? I'm gonna rewrite the cotangent as what, guys? Cosine over sine, and you can. So we have g prime of x equals to sine x times the derivative of cosine, which is negative sine, minus, I'm going to leave cosine x and multiply by the derivative of sine of x, which is cosine x, all over sine square of x. Alright, I'm going to go ahead and simplify this out. So g prime of x becomes negative sine square of x minus cosine square of x all over sine square of x. Alright, it looks like I can do something to simplify this out. This looks very similar to the Pythagorean identity, except that I have a subtraction. So what I'm going to do is, to help me out, what if I factor out a negative 1? Then I have sine square of x plus cosine square of x all over sine square of x. And then at that point, I hope you recognize that now g prime of x is equal to negative 1 over sine square of x, which is equal to cosecant square of x. Negative cosecant square of x. So now we know the derivative of tangent is secant square of x. The derivative of cotangent is negative cosecant square of x. Okay? Alright, next one. Let's pretend you have h of x equals to secant of x. I'm going to rewrite that as 1 over cosine of x. So when I take the derivative of this, so it's going to be cosine of x times the derivative of 1, which is 0, minus 1 times the derivative of cosine, which is negative sine, all over cosine square x. Simplify this out. H prime of x becomes sine of x over cosine square of x. Right? Now, that looks like it's simplified enough, but we can actually simplify this even further. Because what if I rewrite this as sine of x over cosine of x times 1 over cosine of x? Would that be the same thing? Well, you know that sine over cosine is tangent, and then you know that 1 over cosine is secant. So now you know that the derivative of secant is tangent x times secant x, or secant x times tangent x, however you want to look at it. Okay? Last one, can you kind of make a prediction what the derivative of cosecant is going to be? Maybe. So cosecant, if I rewrite it, that's the same thing as 1 over sine, right? So if I do the derivative of cosecant, interesting. Sine x times 0 minus 1 times cosine x. Agreed? All over sine square of x. At this point, then you realize that you have negative cosine of x over sine square x, and we can break that up into negative cosine x over sine x times 1 over sine x, which is technically negative cotangent x times cosecant x. So I'll leave that up there for a moment so you can kind of catch up. I'm moving a little fast just because I know you're still practicing this whole quotient rule, but you understand it. Like, you understand it. It just takes you longer than I take to do it. So I'm going to leave it up there so you can catch up, and then we'll move on. Okay? The last topic that I want to cover with you guys has to do with what is called a higher order derivative. Okay? So let's title this as higher order derivatives. Okay, so here's what I mean by a higher order derivative. Okay? And you don't really have to write this down yet, so we're just going to talk about it. So if I give you a function, then you take its derivative, right? So that's, let's say, f of x equals whatever, and then you say f prime. Agreed? Well, do you guys notice that sometimes that after you take the derivative, you're still left with a function? What if I ask you to take the derivative of the derivative? You can do it. And let's say that you take another derivative and you still have a function left. Could you take another derivative? In other words, you can take derivatives of derivatives, and that's what is called a higher order derivative. Now, how in the world and why would that help us? Well, let's start off with, last time I told you guys that if you have a function, and I told you that that was the position of a function, to find its velocity, you could take the derivative of the position function. Agreed? Well, what if I ask you to find acceleration? You can take the derivative of what? Of the derivative, which in our case was the velocity. Okay? So that's what we're going to do. So we can obtain velocity and acceleration through differentiation. For example, let's pretend s of t is your position function. Okay? To find the velocity, in other words, the velocity function, we're going to say that the velocity function is equal to the derivative of the position function. Okay? And to find the acceleration, so we're going to say the acceleration in terms of t equals to the double prime derivative of the position function. Yes, sir. Technically, yes. The reason why I rewrote it like this is just to connect it back to where we started. Okay? But yes, you're technically correct. Yes, sir.
What happens if you find the derivative of acceleration?
I'm sorry?
What happens if you find the derivative of an acceleration? Like, what do you say?
I didn't hear the last part of an acceleration. What?
What happens if you find the derivative of an acceleration function? So if I don't like this,
After that, it doesn't help you find anything. I mean, you can find it, but not that I'm aware of. Like, I can look into it, but I don't think, as far as this problem goes. Now, remember, derivatives don't always have to do with one thing. So far, we've learned that derivatives can help you find the slope, right? We've also learned that derivatives can help you find rate of change. Now we've learned that derivatives can help you find acceleration and velocity, right? So please don't think as derivatives of like a one set thing. It all depends on the connotation of the problem. Cool? Alright. The notation that we're going to use, okay, just so that you get used to it, a first derivative is denoted as y prime, or f prime of x, or dy dx. Okay, this is just notation. A second derivative will be denoted as y double prime, f double prime of x, or d, and look at where I'm locating the 2, looks like a power of y over dx, and look where I'm locating the 2. Okay? You don't see this very often, to be completely honest, but better to see it than not see it ever. Third derivative would be, guess what? Triple prime. And then d, and then the 3, the y, dx, and then the 3. We're like, that's enough text. We're just going to call it like this now. Okay? And they still look pretty much the same. Therefore, the nth derivative is y and then little n. And this is just notations that you may run into. Okay? That means they're talking about whatever derivative it is. So for example, if you see this on a problem and it's dealing with position, acceleration, velocity, then you know right away that the second derivative is what? The acceleration. Okay? If it was the first derivative, then you would be dealing with the velocity. Okay? So this is just the notation that you're going to run into. Here? This? N. Sorry. Good catch. That's an N. So this is, just so we're all clear, this is just notation of higher order derivatives. Okay? Alright, are we okay with the notations? So let's just practice one problem using these higher order derivatives. You have a falling object on the moon. So it encounters no resistance, right? There's no air resistance in the moon, in case you didn't know that. I don't know how to spell resistance, so resistance, maybe, hopefully. Okay, so the position of the object is given by s of t equals to negative 0.81 t squared plus 2, and the units for this is in meters per second. Okay, so we have some object, I don't really know, I don't care, a hammer or a feather or something on the moon. There's no air resistance, so the position of the object is given by that function. Okay, here's the question. What is the ratio of Earth's gravitational force compared to the moon's? Now, in order for you to answer this, you need to know the force on Earth, the gravitational force on Earth. For those of you that are taking physics, do you guys know the gravitational force on Earth? So, at Earth, we're talking about negative 9.8 meters per second. Meters squared. Oh, yeah, that's right. Okay. So you need to know that. So really what you need to find is the gravitational force at the moon, right? So what do you suggest I do in order to find the gravitational force? So we have the position function, agreed? So S of t equals to negative 0.81 t squared plus 2. If I take its first derivative, it's going to give you what? The velocity. So let's take the first derivative. So what does it become? Negative 1.62 t. So I'm going to write this down. This is the position. This is the velocity. Is that going to help us find the gravitational force? I need the acceleration, agreed? So that means I need to take another derivative. So it becomes what? 1.62, right? So the position was in meters, right? And this is meters per second, which means this is meters per second squared. Agreed? Alright, so now, do we have enough information to answer the question? It says, what is the ratio? So we're comparing Earth to Moon, right? So if I'm writing a ratio, there's got to be a ratio. And on the top part, I'm going to use Earth, right? So Earth is negative 9.8. And the Moon is negative 1.62. Agreed? Who has a calculator? Try it. 6 point what? 05? Do I need any units? No, because the units canceled out, right? So we're just talking about a ratio. The units canceled out. So that means, explain to me what that ratio means in your own words. What's up, Grant? Yep. Very good. Okay, so if they did ask you to explain your answer, that's a very good explanation. Okay. All right, that's all I got for you guys. Homework for tonight, and I am gonna write it down because once again it's super messy. It's page 146. Problems number 1, number 8, 18, 27, 30, 34, 45, 49, 63, 67, 70, 73, 82, 83, 91, 92, 98, and 123.